Good day, students. I hope these videos are helping. They're meant to be just an introduction to every section so that you can move forward and be prepared for class and kind of think about things before you have to do homework. So number one, this lesson is on multiplication and division of real numbers. The topics that we're going to cover, quite a few topics this time. We're going to be multiplying real numbers, two or more of them, and going over the sign rules for those, the sign rules for multiplying. And so we want to remember those. We're going to talk about the idea of multiplicative inverses and then introduce a definition of division based on that. We're going to talk about then dividing real numbers, simplifying algebraic expressions that involve multiplication and or division. We're also going to simplify or determine whether a number is a solution to an equation. So we're going to come back to our friend evaluation, and we're going to use that. And then there's some math modeling with multiplication and division. So those are the topics that are going to be covered in the video. I'm going to go through it fairly quickly. This again is a reminder of things that you should know and an opportunity to improve and get better. All right? So my assumption is you already know the sign rules for multiplication. Sign rules for multiplication. And I just want to review those here really quickly. But if you multiply two positives, then the product will always be a positive. If you multiply two negatives, then the product will always be a positive. All right? And if you multiply one positive and one negative, then the product is negative. Now, why does this make sense? Just as a reminder, really quickly. The positives I'm going to really ignore, but these are the ones that kind of mess folks up. So remember, multiplication is repeated addition, okay? So let's do this one first, a positive and a negative. So suppose I have negative 2 times negative 2, or excuse me, plus negative 2. I said that wrong. Let me go back. Okay, plus a negative 2, plus a negative 2, plus a negative 2. Well, this means 4, because I'm adding negative 2 4 times. 4 times negative 2. But if you look at this, when we add a negative, a negative, a negative, a negative, we learned when we add all negatives, we end up with a negative. So this is negative 8, which means that 4 times negative 2 is negative 8. And that shows us that a positive times a negative is a negative, okay? And that's really important to remember that. So what about two negatives? What's the situation there? Well, the situation there is really interesting. We're not adding negative 2 to itself 4 times. We're actually subtracting negative 2 4 times. All right? So we're sort of undoing the addition. So we're subtracting negative 2 4 times. But if you remember, subtraction is add the opposite. So this really means add the opposite of negative 2. 2, add the opposite of negative 2. Add 2, add 2, add 2. And so this thing here, which was equal to negative 4 times negative 2, all right, where we're subtracting 2, negative 2 4 times, we can see by addition is equal to a positive 8. And so therefore a negative times a negative is a positive. And this is one of the ways you can maybe remember if you forget those rules. All right? Okay, so let's go on. Now, it doesn't matter whether you're multiplying fractions, 2 times negative 1/5. That's a positive times a negative, so it's going to be negative 2/5. All right? Or you're multiplying decimals or whole numbers, the sign rules hold. It doesn't matter what kind of number you have, the sign rules are going to hold. Okay? So then, if you have more than 2 numbers, what you do is you apply the sign rules one at a time. So for instance, you have negative 1 times negative 2 times negative 2 times 3 times negative 4, something like that. Then what you do is you do them essentially 2 at a time. So negative 1 times negative 2 is a positive 2. All right? And then 2 times negative 2 is a negative 4. And then negative 4 times 3 is a negative 12, because that's a positive and a negative, times negative 4. So a negative times a negative is 48. And so one way to do that is to do one multiplication at a time and work your way through it. Another way to do that is count the negative signs. So if I have 2 negative signs, it's positive, but then the third negative sign will make it negative. And then if I have a fourth negative sign, it'll make it a positive again. So I already know my answer is positive. So all I have to do is take 1 times 2 times 2 times 3 times 4. Is just multiply the whole numbers. So I get 4 times 3 is 12 times 4 is 48. And that's the sort of the fast way to do it. Okay? So remember, an even number of negative signs in strictly multiplication is going to be a positive, but an odd number of negative signs in strictly multiplication will be negative. Okay, let's move on. So if you remember, when we defined subtraction, okay, we said subtraction is A minus B is equal to A plus the opposite of B. Now the nice thing is that turned all subtraction problems into an addition problem. And I don't know why, but with positive and negative signs, addition is easier for me to understand whether the answer is going to be positive or negative than it is with subtraction. And so I like that. So we're going to define division in the same way. Division, which is A divided by B, is going to be equal to a multiplication problem, which is A times 1 over B. So in other words, division by a number is multiplication by the reciprocal of that number. So for instance, if I have a negative 4/5 divided by 3, all right, then I can rewrite that as negative 4/5, the original number, times the reciprocal of 3. What that does is that turns my problem into strictly a multiplication problem. All right? And so then I get negative 4 over 15. Okay? Now, I should mention here just briefly, whenever you have a fraction, negative 4/5 with the negative out in front is equal to a negative 4 over 5 or it's equal to a 4 over negative 5. Remember, we're saying the whole number is negative. So we can have a negative divided by a positive or a positive divided by a negative, and that will give us a negative. And that tells us that we can write a fraction in 3 ways with a negative sign. In general, I tend to write it this way a lot, as you see what I did here. But often my final answers, I'll pull that negative out in front of the whole fraction. Now, if you had 2 negatives in there, then that's going to make the whole fraction positive. So that's why you got to keep track of those things. All right? Key thing here is this is our definition of division. All right? So, when we go to divide real numbers, because every division problem can be turned into a multiplication problem, the sign rules for division are exactly the same as multiplication. That's the issue that we need to remember. Okay? So one of the next things we come across then are the properties of strictly multiplication, the things we need to know. Now, even with negative signs, or all real numbers, so all positives, all negatives, no matter what kind of number you have, multiplication is going to be commutative and associative. Okay? Remember, commutative changes the position of the numbers. You know, for some reason, I don't know what 6 times 2 is, but I know what 2 times 6 is. So I can change position of the numbers in the multiplication and do it. Whereas associative chooses which ones I want to multiply first in a string of multiplication. So it changes the order of the multiplication. Doing B times C before multiplying by A, or multiplying A times B before multiplying by C. Now, the more important properties are the next ones. No matter what number A that we have, if we multiply it times 1, we still get A. That's the identity property. The inverse property, if we multiply a number and it's reciprocal, it's always 1. Okay? Now, property of -1, if you multiply by -1, you basically change the sign of the number. Okay? And the double negative property, if you have a negative, essentially a -1 times a negative A, that's going to then give A. All right? So those are the properties of multiplication. There are some good examples in your text if you're following along, and I'll let you look at those. And I would encourage you to do it, and we'll look at some problems here in just a moment. The next thing then that we talk about are really negative signs in front of parentheses, and then we can simplify some expressions. So this isn't really a property, but if you have a negative in front of a set of parentheses like this with an expression, then that negative is like saying -1 times this. So by distributive property, all right, that -1 can be distributed through, and you get a -2x. -1 times 2x is -2x. -1 times -7 is a +7. So it changes all the signs from inside the parentheses. And so the key to remember is that a negative in front of the parentheses is really a -1 times. And if you can remember that, then you take that -1 and you multiply it through on a distributive property. This is a really common source of negative sign mistakes. So I want to mention it so that you keep it in mind when we start to simplify algebraic expressions. Okay? All right. So let's go to the next slide. So when we get to where we need to simplify an expression like this, all right, the directions are simplified. That basically means add and subtract like terms. But it also means perform any operations that need to be performed. So it basically means add and subtract, multiply and divide. And so in this case, we are going to want to do the distributive properties that we see. And then remember, this is subtracting a set of parentheses. So that's like saying -1 times each of those inside the parentheses. And so there are a couple of distributive properties here. So 5 times 2y is 10y. 5 times -9, if you wish, is a -45. Or 5 times 9 is 45, but I'm subtracting it. So there are a couple of ways you can think of that. Then -1 times 9y is -9y. And a -1 times a -8. Subtracting 8 is like adding a -8. So I can say -1 times -8 is a +8. So notice how these signs just changed. All right. Once we're at this point, then we can collect like terms. And generally what we do in that case is we can reorder them. So we can put by commutative property of addition, 10y minus 9y. And so, this is really adding a -9y. So I can put those together and that's okay. Well, that's a little bit. Let me be slightly more mathematically sound. Because it's adding a -9y, I'm adding a -9y. I can switch the positions, all right, and do that. And then same way, because I'm adding a -45, using the add the opposite definition of subtraction, I can put +8 plus a -45. Right? Now, that would be showing everything correctly. However, what you could have done is you could have just said, I'm going to collect like terms, 10y minus 9y plus 8 minus 45. And so you gather the constants together and you gather the variable terms together. And because it's addition, and you could change this addition of negatives back to subtraction, you can just skip ahead to this step right here. That's what becomes a shortcut. And sometimes what confuses students, there's no commutative property of subtraction. However, because you can think of it as adding the opposite, you can move them. And so that's a little bit strange, but something you want to pay attention to. All right. So 10y minus 9y is 1y. All right. And then 8 minus 45 is a -37. And so we get y minus 37. You can leave it as 1y, but it's accepted to change it to y. Okay? And that's how you're going to collect like terms on a more complicated type problem. But notice you're multiplying first, so you need to remember the multiplication rules of signs. All right? That's what we did there. Once we do that, then we're adding and subtracting, and so we need to make sure we know how to add and subtract positives and negatives. All right? This is a case where using a calculator to check your arithmetic is fine. So for instance, if I wrote 10y minus 9 here, and I'm saying, okay, I multiply by 5, and then 5 times negative 9 is negative 45. Don't just write 9, okay? So I make sure I can take negative 1 times 9, negative 1 times negative 8, and see that the signs are correct. And then when you're adding down here, if 8 minus 45, if you don't recognize that as negative 37, go ahead and put that in a calculator and check it. All right? And then make sure you can get those problems right. Don't make arithmetic mistakes. That's kind of the goal there. All right? So what I want to do here is I want to give you another problem, and I want you to do it, and then you can pause the video and do the problem at home, and then I'll show you the work. Alrighty, there's your problem. Go ahead and pause the video and do it. All right, now you're back, so you probably have simplified it. So let's go through this. The thing I notice is I have a 5, a distributive property here, so I'm going to take 5 times 3y, which is 15y, and then 5 times negative 1, which is negative 5, all right? And then I have a negative sign in front, which is really negative 1 times. So negative 1 times 14y is negative 14y. And negative 1 times negative 2 is plus 2. And so now I can rewrite this as 15y minus 14y minus 5 plus 2. I'm collecting my like terms. And so 15 minus 14 is 1y. And then negative 5 plus 2 is negative 3. And I can rewrite that as y minus 3. All right. So did you get it right? If you did, great. If you didn't, what mistake did you make? And then try and understand what error you make. The biggest error, people forget to do the second multiplications. And then after that, they might add things wrong. So how could a calculator help you to get those right or remember to do things? Okay, next problem. Okay, the next problems look like this, and the directions are determine whether given number is a solution to the equation. And so whenever we want to determine whether something is a solution, that means we need to evaluate. And evaluate always means substitute. All right? And so they're not going to tell us to evaluate it. That's something you have to know. So the number we're given is negative 9. And what they're saying really is W equals negative 9. So therefore, for every W, we have to substitute. So I go 6 times negative 9 plus 2 equals 4 times negative 9 minus 10. Now, these are just numbers, arithmetic expressions, so I need to simplify them, all right? So, by order of operations, I do the parentheses first. So 6 times negative 7, that's the left side, and then that's equal to negative 42, okay? And we're really asking, are these equal? In order for it to be a solution, they would have to be equal. So it's really a question mark above our equals here. And then 4 times negative 9, working on the right side, is negative 36 minus 10, which is a negative 46. How'd I do that? Negative 36 plus the opposite of 10. So I'm adding two negatives, which is a negative. That's how I got negative 46. So these are not equal. Therefore, negative 9 is not a solution. And so you can write your answer as a complete sentence. And that's how you do those problems. Using evaluate to check whether you have a solution or not. Alrighty, I think that's all I have for you guys on this lesson. There'll be a second video for section 1.8 where we talk about exponents. All right, see you later.